Continuing with section 5.1. Let f of x be x squared plus 1. So parabola shifted up 1 unit. Estimate the area under the curve between 0 and 1 by using two rectangles with an underestimation. Alright, so first I'm going to draw a picture of this thing, okay? So let's see. Parabola shifted up 1 unit. Looks something like this. So that's y is equal to f of x. All right, now I'm looking at the area under the curve between 0 and 1. So here's 0. Here's 1 right here, okay? Now, what does it want me to do? It wants me to find this area between 0 and 1, between the curve and the x-axis here. And actually, it doesn't really want me to find it exactly. It wants me to estimate by using two rectangles with an underestimation. So let me draw a couple of rectangles here with an underestimation. All right, so what I'm going to do, I'm going to go ahead and use, let's go ahead and use this blue. All right, so if I want to break this interval up into two equal parts, I'm going to break it up like that. I'm going to call this 1/2 on the x-axis, okay? Now, it wants me to use two rectangles, and it says with an underestimation. So what I'm going to do, instead of starting here and going left to make my rectangle, I'm going to start here maybe and go right. And then the same thing here, I'm going to start here and go right. So actually the rectangle area is going to be here and here. So if I draw the rectangle starting at the left and going right for this curve, notice how it's an underestimation because I'm calculating the area of shaded region. But the actual area under the curve also includes this and this, right? So therefore, I have my underestimation there. All right, now let's talk about that area. How do I estimate? I say area is approximately width times height of the rectangle, right? So what's the width of this first rectangle? It's 1/2, right? Times the height of it. How tall is it? It's this tall, right? But what is that? Remember, this is an x value of 0 right here. Isn't it the same as my function value f at 0? So my height's going to be f at 0 for this one. Plus the area of my second rectangle. What's the width here from 1/2 to 1? It's 1/2 times the height. Now, the height of this rectangle is not f evaluated at 1. F evaluated at 1 is way up here, right? That would be from here to here. But no, the height of the rectangle is actually this, right? So it's the same as f at what? 1/2. All right, so let's see what this gives us. This gives us 1/2 times, evaluate f at 0, so 0 squared plus 1, plus this 1/2, evaluate f at 1/2, so that's 1/2 squared plus 1, 1/2 squared plus 1. All right, so that's 1/2 times 0, not 0, I can't do math, times 1, plus 1/2 times, isn't this a fourth? A fourth plus 1 is what, 5/4? All right, so that's what, 1/2 plus 5/8. And what does that give me? Something like 1.125 maybe? Yeah, 1.125 is my approximate area under that curve using two rectangles with an underestimation. All right, let's look at part B. Part B says, let's find the area under that curve this time by using four rectangles with the center rectangle on the curve. Part B says 4 rectangles with center on curve. I'm just going to abbreviate. Y'all have the notes here. With center on the curve. So let's see what that's going to look like this time. So if I end up drawing my picture, I'm going to draw a picture like this, okay? I'm going to draw this curve. My parabola shifted up 1 unit. It's maybe going to look like this. Y is equal to f of x. Now, I want from 0 to 1. I'm going to go pretty far out here from 0 to 1 just because I'm going to draw 4 rectangles. So I want enough space where I can see them. You know, I don't want to crunch up all my work whenever I do this. All right, so what do we want? We want this area from 0 to 1 between my curve and the x-axis here, okay? Now this time they say, let's break that thing up into what? 4 equal sections. So I'm going to take this interval, break it in half right here. So here is 1/2. And I'll go like that. Then I'm going to break each one of these sections up in half. So maybe I'll split it right here and go up like that. That'll be a 1/4, right? And then maybe halfway between a 1/2 and 1, I'll break it up again. And what is that? 3/4? Actually, let me come back in here and draw this with black. If it helps you, get some colored pencils here. Get a couple of different pens that are different colors and so forth. Now, notice that we do not have rectangles yet. We have almost rectangles, but this curved top does not make it a rectangle. To be a rectangle, it needs to have a straight top somewhere, right? Now, we looked before making rectangles starting at the right where it hits the curve and going like that. We looked also making rectangles where it hit the curve at the left and going straight across like that. But this one's a special kind of rectangle they want, where they want the center of the rectangle on the curve. So what does that mean? That means that, okay, if this is going to end up being a rectangle, the center of it's going to be right here. And what you do is you go up, up, until you hit the curve right there. And then you make a rectangle going left and going right like that. Same thing for the rectangle that's going to be formed here. Go to the center of this interval right here. Go up until you hit the curve, and then go left and go right and form you a rectangle. Same thing here. Center of what will be a rectangle. Go left and go right. Center, go up, go left, and go right. Now, as you can see, if I calculate the area of these rectangles here, I'm going to have some overestimation here of the actual area under the curve, and I'm going to have some underestimation, right, because of that. So this might give me a better estimation, okay? Sometimes your teacher, your book, or whatever is going to do them this way. All right, so let's identify where we're at here, 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 and here, okay? The easiest way to do that is, what's halfway between 0 and a 4th? It's going to be 1/8, right? What's halfway between 1/4 and 1/2? Well, how do you find the halfway mark? You average them, right? So how do you average two numbers? Add them up, divide by 2, right? What's 1/4 plus 1/2? 3/4? What's 3/4 divided by 2? 3/8? Now look at the pattern we started. We started 1/8, 2/8, 3/8, 4/8. So what would this be then? 5/8. Draw that a little neater. 5/8. 5/8. And then 6/8 is what? 3/4 simplified. So this is 7/8. And that's 8/8. 8/8 simplified is 1. All right, now let's actually estimate the area here using those rectangles, okay? So what is my area going to be? Well, use this first rectangle. What's the width of it? From 0 to 1/4, that's a width of what? 1/4. Times the height of the rectangle. It's going to be f evaluated at what for the height here? Well, the height is the center of the rectangle, right? So it's going to be right here. So it's going to be my curve f evaluated where? At 1/8. Plus, how about the area of my second rectangle here? How wide is that from 1/4 to 1/2? That's 1/4 in width times the height. What is the height of this thing? Is this high, right? And what is that high? My function f evaluated at what? 3/8. Plus, my third rectangle, how wide is it again? 1/4. We made them all the same width here, didn't we? How tall is it now? My function f evaluated at 5/8. And for my fourth rectangle, there's a width of 1/4. Its height is f evaluated at 7/8. Now make sure you have the same number of sums here that you have as your number of rectangles, because what you're really adding up is the area of each rectangle, right? You have 1, 2, 3, 4 rectangles, have 1, 2, 3, 4 sums. All right, now I can factor a 1/4 out of all these terms here. So if I factor a 1/4 out, what am I left with? F of 1/8 plus f of 3/8, just to make it a little neater, plus f of 5/8 plus f of 7/8, right? So that's approximately 1/4 times, what's f at 1/8? Sub in 1/8 right here for x. So you have 1/8 squared plus 1. Plus f of 3/8. So you have 3/8 squared plus 1. 3/8 squared plus 1. Plus f of 5/8 will be 5/8 squared plus 1. And f of 7/8 is 7/8 squared plus 1. All right, now at this point, just take your calculator, punch in those buttons and so forth, so you don't have to do this by hand. Actually, probably like in a regular classroom, you would show your work up to this point right here, and then you would just put it in a calculator, okay? Just kind of preparing now for next semester if we're face to face. I got 1.328125, and it didn't tell me how to round, so I'm just going to put that, okay? Just pay attention to Wiley, how many decimals it tells you to round to. All right, I want to look at this one next. Our next example, we're going to have our function is going to be f of x is equal to 2 times the cosine of x. And they want me to estimate the area between the graph of the function 2 cosine of x and the interval from negative pi over 2 and the interval for negative pi over 2 to pi over 2. And they want me to use 5 rectangles with left endpoints. Use 5 rectangles with left endpoints. All right, let's see. What do we do here whenever we're estimating the area under a curve? We draw a picture of the graph. So I want to draw a picture of this thing right here. What is that going to look like? That's going to look like the cosine function, but a vertical stretch of 2 units, right? So whenever I draw a picture of this stuff, I'm going to do something like, let me come out a little further. I'm going to do like this, and I'm going to say, okay, this is 2 then. Instead of being at 1, we're vertically stretched by a factor of 2. What does my cosine function do? It does like this, right? And so forth, one period of it, right? All right, now where do I want to go? Between negative pi over 2 and pi over 2. So I'm going to need to consider drawing this side as well, right? Now, where does your cosine function hit the x-axis here and here? Think about it. Where's your cosine function? 0. Isn't cosine function 0 at pi over 2? And negative pi over 2 like this? Yeah. So what am I looking at? I'm looking at the area underneath the curve, or between the curve and the x-axis, between negative pi over 2 and pi over 2. So what I'm going to do is I'm going to erase all this, get it out of my way. Don't want to focus on that. I just want to focus on this. And actually, let me draw the top a little better. Okay, that's kind of a, for lack of a better term, piss poor way to draw it. Let's see. There we go. All right, what do they want me to use here to estimate that area under the curve? 5 rectangles with a left-hand endpoint. All right. So I'm going to break this interval into 5 rectangles, okay? Maybe what I'll do for right now is I'll lose this axis right here. Okay, 5 rectangles. So let me see, maybe 1, 2, 3, 4 will give me 5 rectangles if I do it that way. So in other words, I'm going to do this. I'm going to do stuff like this. Boy, that's not a straight line at all, but it'll get the job done. All right, so one rectangle is going to start looking like that. If it has left-hand endpoints, that means you hit the curve on the left-hand side and you go this way, and that's your rectangle with that height where you hit the curve on the left. So let's think about this rectangle then, okay? What is that going to look like? That's going to look like what? Let me erase the 2, get it out the way as well. Where it hits the curve on the left-hand side, and it goes right. What about this rectangle? Where it hits the curve on the left, and it goes right. What about this rectangle here? Tell you what, let's go to this one next. Where it hits the curve on the left, and goes right. How about this rectangle formed here and here? Where it hits the curve on the left, and goes right. Ooh, that's not good either. All right, now notice this rectangle. Where does the curve on the left and goes right? It's a rectangle with no height. Well, that's fine because that's what they told me to use, right? So I'm stuck with it. All right, now let's find out what my breaks are right here. In other words, what is this point right here? What is that point there? What is that point there? What is that point there? Not only that, but also I want to know the width of each one of these rectangles here. How do I find the width of each rectangle? Width of rectangle. Okay, that'll be equal to the width of this interval divided by the number of rectangles. Let's put that width of interval divided by number of rectangles. Width of interval divided by number of rectangles. So what's the width of the interval from negative pi over 2 to pi over 2? Well, this width right here is pi over 2. This width here is pi over 2. Pi over 2 plus pi over 2 is what? 2 pi over 2, or pi, right? Divided by the number of rectangles. How many rectangles? 5, right? So the width of each rectangle, width of rectangle is going to be pi over 5. So now how does that help me over here? That helps me here because what do I know? I know the width of this rectangle is pi over 5. So to find this point right here, what would I do? I would say negative pi over 2 plus pi over 5 more. So maybe I'll come down here and do some scratch work. Maybe I'll say negative pi over 2 plus, has a width of pi over 5, we just said, plus pi over 5. Well, what is that? That's just negative 5 pi over 10 plus 2 pi over 10, right? what I do, I just came up with a common denominator on each one of them. What does that give me? Negative 3 pi over 10? So what does that tell me? That tells me this point is negative 3 pi over 10, right? So now how do I find this point right here? Well, it's 3 pi over 10 plus this much more, right? How much is that much more? The width of the rectangle, which is pi over 5. So to find this point here, I would say negative 3 pi over 10 plus pi over 5. Negative 3 pi over 10 plus pi over 5. Well, what does that give me? Negative 3 pi over 10 plus 2 pi over 10. What does that give me? Negative pi over 10. So this point is negative pi over 10. And how do we find this point? We add what? Pi over 5 to negative pi over 10. And we'll get positive pi over 10 here. Find this point, do the same thing. Take pi over 10, add pi over 5. Add the width of that rectangle. So what is pi over 10 plus pi over 5? Well, that's pi over 10 plus what? 2 pi over 10, which gives me 3 pi over 10. And let me make sure I did this right, okay? So if I take this 3 pi over 10 and I add pi over 5 to it, I should get pi over 2. Let's see, 3 pi over 10 plus pi over 5 is 3 pi over 10 plus 2 pi over 10, and that's 5 pi over 10. But what does 5 pi over 10 give me? Pi over 2. Oh man, guess what? I did it right. Yay, I get a cookie. All right, so all this was right here was scratch work. There goes my eraser. All this was scratch work. So I'm going to erase that. All right. So now let's see. I need to come up with what? An estimation of my area under this curve. So my area is going to be approximately what? Width of a rectangle times the height, right? So what's the width of this first rectangle? Well, what's the width of all my rectangles here? Pi over 5. Pi over 5 times the height of that first rectangle. What is the height of that first rectangle? It's right here, right? It's what? My function f here evaluated at negative pi over 2. Negative pi over 2. So that takes care of this rectangle down here. Plus, how about the area of this rectangle? It's going to have a width of pi over 5 times its height, right? So what's the height going to be? It's going to be my function f right here, evaluated at negative 3 pi over 10. Function f evaluated at negative 3 pi over 10. Takes care of that rectangle. Plus, my next rectangle, the width again is the width of all of them here, pi over 5, times the height of my rectangle. What's the height of this rectangle here? It's right here. F evaluated at where? Negative pi over 10. So that takes care of the center rectangle, right? How about this rectangle? Width of pi over 5 times the height of what? F evaluated at what? Positive pi over 10. Takes care of that rectangle. How about my last rectangle right here? What is the width? Well, yeah, pi over 5 times what is the height of it? The height of it's this part, right? From here to here, which is f, my curve, evaluated at 3 pi over 10. All right, let's see. So this is what? Pi over 5 times, what's f evaluated negative pi over 2? 2 times the cosine of negative pi over 2. 2 cosine of negative pi over 2, right? Plus pi over 5 tell you what, let's do this. Instead of doing all that, let's do this. Let's say pi over 5 can be factored out of all these, okay? So I'm going to take pi over 5 out of all these. And f evaluated negative pi over 2 is 2 cosine negative pi over 2. Plus, I already took the pi over 5 out, right? So it's just f evaluated negative 3 pi over 10. So plug in negative 3 pi over 10, you get 2 cosine negative 3 pi over 10. Plus, I already took out the pi over 5 over here. So I have f evaluated negative pi over 10. So 2 cosine negative pi over 10. Make sure I'm still in the shot here. Yeah. So where were we at? We were here, right? We just finished that. Plus, we're right here now. Pi over 5 I already took out. Let's evaluate f at pi over 10. So 2 cosine of positive pi over 10. Done with this part, right? Plus pi over 5, which I already took out, times, or plus, right here, I'm going to have 2 cosine of what? 3 pi over 10. All right, let's just go ahead and put that in our calculator. Now, which mode do we need to make sure we're in? If we're in calculus and we're talking about a cosine, we're in radians, right? So whenever I did this, I came out with about 3.868. 3.868 as my estimate, okay? Now, this happens sometimes. Sometimes when you do these, you get a rectangle that has a height of 0, actually. And that's fine because of what they're asking here. 5 rectangles with a left-hand endpoint.